Good afternoon, everyone. Thank you once again for joining us here on Facebook. We're so excited to have you back this afternoon for our regular installment of Minnesota's Night Skies. We hope to see you soon at the museum. The museum is once again open on Fridays, Saturdays, and Sundays, and you can get information on our website about how to get tickets in advance. As the summer progresses, we're hoping to be open more days, so keep looking for information on that so that you can join us at the Bell Museum sometime this summer as life returns to a little bit more normalcy. We are going to have some fun exhibits this summer on bugs, so once again, we hope to see you there. So as always on Facebook, we have Tad from our planetarium staff who's going to be leading us on this adventure to explore what we can see in the Minnesota night skies. We love to hear your questions, so please add all of your questions into the comment section on Facebook, and we'll save some time at the end of this presentation to be able to answer your questions live. All right, thanks for joining us. Tad, take it away.
All right, thank you so much, Amber. All right, good. Well, you know, if you're watching it live, good afternoon. If you're watching this in the future, I hope the flying cars are working out well for y'all. My name is Tad Thaddeus. I work here at the Bell Museum. You might have seen me in the planetarium before if you come visit us. And I am excited to take you on a tour of our June sky. Before I do that, I do want to do a quick acknowledgement here that the Bell Museum, where I am sitting right now, does sit on the traditional and treaty land of the Dakota people, who, along with the Ojibwe people, are the indigenous peoples of this land, Minnesota, Mokoche, Minnesota. In recognition of this fact and to honor the Dakota people for their care and knowledge of this land, we waive general museum admission for Dakota and all indigenous peoples. And today, as we explore the sky, I will be talking most about Greek and Roman constellations, Greco-Roman constellations. If you want to learn more about some of our indigenous constellations and indigenous sky knowledge, I highly encourage that you check out Native Sky Watchers. Run by Dr. Annette Lee. Native Sky Watchers is a Minnesota, I don't even know the right word for it. It is an amazing work going on by Dr. Lee to bring this knowledge to all of us. So Amber has that link, should be putting in the chat, but Native Sky Watchers will take you to Dr. Lee's great page. There are programs that go on throughout the year. I get notifications all the time about them going on, so I hope you can join in some of those. All right, but I'm going to go ahead and bring up my screen share here for exploring the night sky. And we are starting off, we are going to be exploring our June sky, but we are starting off here in today, actually, tonight. I'm using a program called Stellarium. If you've tuned in before, you've seen me use this. It is one of my favorite programs for stargazing. Stellarium is a free and open source program where you can explore the night sky and do it from your laptop, your computer. They also have a phone app as well that I use quite extensively. Now, I've taken us here to later tonight because I do want to point out one thing that is happening tonight and also how disappointing it's going to be. Starting here just a little bit past 9 o'clock, 9:15, if you're looking out at the sky and you have clear skies, you might see a handful of stars out there, and you might also get a chance to see a light that is moving across the sky. Tonight is one of the nights where the International Space Station is passing above us. We can see the International Space Station there, going above, marked out the constellation of Gemini. Now, the International Space Station is very easy to see, and it goes over our heads on a regular basis. Marked out here, in fact, Stellarium is marking out that I've actually clicked on the Crew Dragon 2 component of the ISS. Now, I say this is amazing. It's always amazing to see the ISS going 17,000 miles above our heads around the Earth every 90 minutes. This football-sized field international engineering collaboration has been our permanent space outpost for over 20 years now. It's super cool. But tonight, of course, it's going to be raining on us here in Minnesota. So that's fun. However, it is a regular occurrence. The ISS goes around the Earth every 90 minutes. And so as we go forward into the month, in fact, as we get to the end of the month, May 31st, there is another pass projected at 9:30. So showing up in Stellarium again as a bright point of light. We'll Try to get it moving along there. There we go. As a bright point of light moving now from the west-northwest up to generally southeast, we should see another one then. Now, that is projected because May 31st is quite a ways away from the 19th, and the ISS orbit does change every so often by just a little bit. If you want to see exactly when it is going above your head, there is a great website for that. It is NASA's Spot the Station. spotthestation.nasa.gov. Hopefully we'll put that in the chat there as well if you want to click on it. There is an interactive map there where you can click and view where it is coming above your head from anywhere in the world. There's also notifications as well. That's how I actually reminded myself to mention it today. And if you're curious on what's going on the space station, if you're just curious, in fact, who's up there right now, there's another great website. It's called howmanypeopleareinspaceriightnow.com. I love that website because it answers that very simple question. How many people are in space right now? I just checked earlier, 7. All right, now we are here looking in Stellarium and we're almost to the beginning of the month, but I'm actually gonna come back in time a little bit because the great thing about the space station is it gives us a great way to differentiate, to tell the difference between what is up there. Watching the space station go above again, we see that it is moving, and you might see there are a few other spots of light moving, a few other satellites going above us, but there's also a lot of stationary points of light. In fact, as we look along here, going into the June sky, we have some very bright points of light visible in the early evening. As the ISS disappears here, and we take a closer look at our west-northwestern horizon, we can see a very bright point of light close to the horizon, kind of behind a tree there, but that is the planet Venus. If we travel a little bit further upwards from Venus, further to the west, there's a brighter reddish point of light, which marks out the planet Mars. So both Mars and Venus visible here at the beginning of the month. In fact, we'll just jump ahead to June 1st, just so we know we're looking at the beginning of the month. And we can see they're there. Venus is kind of right below the trees right there. You might be thinking, why is he bothering to point that out? Well, if we keep going forward into the month and we keep our eyes on Venus down there, and we're still looking around 9:30, Venus will be getting higher and higher in the sky. So throughout the month of June, we'll have both Mars and Venus visible. In fact, near the end of the month, Venus reaches its highest position above the horizon, its greatest elongation. And it will be trivial to see. If you are anywhere where your view is not blocked by, well, trees or buildings, you'll see Venus, our evening star, the brightest planet from our perspective here on the Earth. If you get a chance to look at it through a telescope, you might start to see a little bit more. In fact, well, it depends on how you're looking and where Venus is as well. As one of our interior planets, a planet closer to the sun than the Earth, Venus has very distinct phases. So as we look here at the end of the month, it's almost fully lit up. I'm going to jump backwards though to June 1st. And we're right in the horizon, so let's come backwards a bit. Oh, and look at that. It's still almost as bright. You know what? Let's run time forward, though. Let's do that stepwise through the month. Looking at Venus here at June 1st, if we keep going forward, we see some motion here from our view. But if you keep an eye on the top edge on this shadow, in fact, the terminator here, not the killer robot, this is the area, the line in between where it's light and dark. If we keep an eye on that, we can see it growing just a little bit by bit by bit. As we keep going, and I'm just going to go all the way through into July, that terminator grows larger and larger as Skynet attempts to take us over. I mean, as Venus comes in between us and the sun. So the light and dark parts of Venus that we see are different parts of it lit up by the sun based on its position between us and the sun, or it going around the sun. Of course, it goes away from us as well, too, as we look at it. That's one of the easiest things to spot on Venus. Otherwise, as we just seeing there, it's a planet that is very, well, just to our eyes, it's not, in a sense, that exciting. I'm not going to call it boring. Don't worry, I'd never say that. But it's a very uniform color there, very bright white, very bright yellow as we look at it. Our spacecraft, though, that have gone to Venus, like Magellan or Atsuke, have given us incredible images of the surface. I highly encourage you to look up some of those to learn more about what's happening on the hottest, brightest planet in the solar system. Further up along, though, we do have Mars. I'm going to try not to talk a ton about Mars because I know I do it every month. We are always talking about Mars for good reason. Two things I think I'll mention right here, right now, then. One, I hope you've been keeping up on the Perseverance lander, and in particular, the Ingenuity helicopter. Ingenuity is the first aircraft on Mars. Really, in many senses, it is the very first powered aircraft on another planet, ignoring things like the Sky, of course. But Ingenuity has made almost, I think it's up to half a dozen or so flights across Mars. It has gone both return flights there and back, and also scouting out new landing sites. It has worked amazing. I can't even describe how well this mission has gone off, has worked. It was originally, it very much was a proof of concept mission. Oops, Mars is disappearing on us. 1 second. It was very much a proof of concept mission, but it has done its job fantastically, if that's a word. And really, I think it has really paved the way for future drone missions on Mars, essentially. The other thing I want to mention is that Perseverance is not alone. As of just about a week ago, China's Tianwen-1 spacecraft successfully landed the Zhurong rover on the surface of Mars. Apologize if I mispronounced that, but it is the fourth spacecraft now active on Mars, just right now, four of them working. It is the first spacecraft sent by China to Mars, and the Tianwen-1 orbiter was the first. The lander was also its first. It also includes a rover as well. It's incredibly exciting that another space agency, another country has gotten to Mars successfully. It's very exciting. It joins another first as well from now a few months ago, but the United Arab Emirates Al Amal mission, the HOPE mission, also reached Mars successfully. Another first. The UAE having first time to Mars, and it's an exciting time. There's so much going on there. But I think that is all I will say about it. So because there's so much more to see here. All right, looking at our sky here, we have these planets. If you've been watching the sky through the month, I will also mention Mercury has been visible through May. It will be visible through the end of May, but sinking below the horizon as we reach into June. It's just barely visible down there on the horizon view here in Stellarium. But if you want to see Mercury as well, that's also possible for the next couple weeks. Looking at the stars, though, looking much further away. If you are looking for Mars there, you know what? You probably won't have those nice labels. We generally don't. But hopefully you're looking when it's even a little bit darker, so you can see some more of the stars. Nearby Mars, if you're looking, you can find the two stars, Castor and Pollux. Excuse me, Castor on the left, Castor on the right, Pollux on the left here. These are the two brightest stars in the constellation of Gemini, or the twins. They've popped up a few times here. Both the International Space Station is flying by them, and Mars is right nearby them as well. Now, Gemini is sinking below the horizon pretty quickly. As we reach into June, we'll start observing here at 10:30. Gemini and Mars will be close to the horizon. Venus has sunk below it now. But as we look further along, there's still a lot more to see. Now, if you're observing from here inside the city, which I do, I'm right here in St. Paul, there's a few very distinctive stars that will stand out, probably more than you might get a chance to see here on Stellarium, on our screen share. In particular, though, if we come over a bit to the west, looking west-southwest, almost straight up from the horizon, about 2.5 hand lengths or so, there's a bright star called Regulus, brightest star in Leo, or the Lion. Now, there are actually many bright stars in Leo. Algeba at the top of the Lion, or excuse me, the middle of the line, Algeba here, Aljanubi here. I apologize, I'm not a native Arabic speaker. Sorry, I often get tripped up with these names. But they make up the head of the lion, which is a pretty distinctive sort of backwards question mark. In fact, in astronomy, this is actually officially known as the backwards question mark. Going back further along to the nebula at the tail of Leo, we have another distinctive triangle, which, well, you already know the joke there. But it's a very bright constellation. And by that I mean all of these stars are pretty easy to see from inside the city. I do recommend starting with looking for Regulus though here at the base of Leo. One way you can do that again is looking, if you know your directions. You can also come over from Pollux and Castor, sort of looking across and about a hand width up or so. That helps guide you to Regulus and then looking for those distinctive and simple shapes. While you're doing that, if you have binoculars or excuse me, a telescope, you could also look along to the back of Leo near this triangle. Here, as we go into June, we will have an opportunity to spot the asteroid 4 Vesta. Now, as we can already see just from what's there, it is in our sky very, very tiny. 4 Vesta is an asteroid. It's part of the main asteroid belt. And it's a 350-mile brownish ball of rock and metal, to put it quite simply. It is a really important asteroid, though. 4 Vesta is the second largest asteroid in the entire asteroid belt. So the largest is Ceres, relatively good book series that features Ceres quite a bit. In fact, as we measure things in the asteroid belt, Vesta is the second largest, and by mass, so like by total amount of what's there, it's a good 9% of the asteroid belt. So a good chunk of all that rocky metallic material is right there in Vesta. And because of this, it's this very large object in the asteroid belt, or massive object, it was actually the target of a space mission. Vesta was actually targeted by the Dawn spacecraft, or it was the mission objective of the Dawn spacecraft, along with Ceres. And the Dawn spacecraft, quite appropriately enough, it went to Vesta because it was there to study the beginning of the solar system. So objects like Vesta are the remnants of all the stuff that makes up everything we see here around us now. And so learning what it's made of tells us then what the early solar system was like 4.5 billion years ago. We also study Vesta as well. It's important to go there because we've also been pretty sure we've been studying it here on Earth. Vesta seems to be have had multiple impacts in the past, and it's actually has had many large objects thrown off it by those impacts. So there's been a lot of debris from that. And we found that debris here on Earth as meteorites. In fact, there's a collection of meteorites attributed to Vesta, and these are known, these meteorites from Vesta are known as the Howardite, Eucharite, Degenonite meteorites. Amber is hopefully going to put that one in the chat because I'm pretty sure I just didn't do service to that name there. The HED meteorites, though, for short. If you know a geologist, ask them all about them. At least the geologists I know would love to talk your ear off. While you're looking for Vesta, though, look for some things in a sense nearby. Vesta is part of our asteroid belt. It's a couple 100 million miles away. Nearby Vesta, though, as we see it from the sky, if you have a telescope, you can also find the Leo Triplet. All these names have popped up here. The Leo Triplet marked out in front of us is a collection of 3 galaxies. And although they seem close, they're actually much further away. They are about 35 million light years away. But they are a close associated group of galaxies. They're a great one to observe because they give us a nice view of the different, really sense all the different types of galaxies that we can, or some of the different types of galaxies that we can see. Spiral galaxies at essentially random orientations to us. So we see one galaxy up here. I'll get the names up because I often forget them. The Hamburger Galaxy, because of the shape there, but also known as NGC 3628. Is a possible spiral galaxy. It's edge on to us though, so it's hard to make out that exact shape because we're seeing it from the side. Given the general morphology of it though, a spiral seems likely. Other galaxies are much easier to tell. For example, down here, M66, one of our Messier objects, is a nice, almost perfectly face-on spiral galaxy. We can see those arms, those spiral arms very nicely in this image from, I believe, the Hubble, along with some background stars, although I shouldn't say background. They're actually stars, they're foreground stars in our Milky Way galaxy. And then finally over here, M65, another spiral galaxy, bit more of a tilt to us though, and some more very distinctive dark dust lanes going around this galaxy here. So some galaxies like M66 back there, more well-defined or very different shape of spiral arms. I think they're both well-defined. And we can see some darker striations here through this galaxy. The Leo Triplet is a favorite one for amateur astronomers. Very easy to see. They're very bright. Also very easy to find. Going down from Zosma to Sherton, we can find the Leo Triplet right there. And then we also have Iota Leo there, Leonis here. So very nicely located for us. Now, as we look in the sky, oh, there's so much more. I've turned on star labels here. I've turned on deep sky objects. And I'm going to hop over to Arcturus. Now, of course, looking in the sky, you probably don't have those labels, but just look for the brightest stars. In particular, actually, before I go to Arcturus, as we look here to the southwest, we're going to look pretty high up in the sky, but we can find the Big Dipper. Now, the Big Dipper is right over here, part of Ursa Major, or the larger bear. We can see him looking a little grumpy there as he's stuck in the sky. But taking the handle of the Big Dipper, the arc formed by the last 3 stars, and following it downwards, following the arc downwards, we do come to the bright star here, good old Arcturus. Now, Arcturus there is the brightest star in the constellation of Bootes, the herdsman or the farmer. We want just Bootes up there, hopefully. In fact, in different mythologies, Bootes here is the first person to invent the plow. And the plow we actually do see nearby him. It's the Big Dipper, but not a spoon. We have a handle that pushes the blade of the plow through the sky. Or, of course, hopefully through the earth now that we're right in the midst of summer. Arcturus is very easy to find. It is a red-orange giant star. It really stands out. But don't stop there. As you're looking at Bootes here, there's a nice sort of triangle of stars formed by Arcturus and the top 2 stars of Bootes. If you take that triangle or that spike and you head downwards, almost straight down, you'll find a bright bluish star known as Spica. So you spike down to Spica from Arcturus and Bootes. And there you can find the constellation of Virgo, the maiden. All right, all those constellations, don't worry, we'll come back to those. But we're hoping just leave Virgo up here. The goddess of the harvest in some different mythologies. Spica translated to ear of wheat or grain of wheat, and we see that represented here in that image as well. All right, but we are headed into summer, and if you've been looking at the date and time, you might be a little confused because it's still stuck on June 1st. The nice thing though is that observing the sky over a certain month, things usually stay pretty much the same. In fact, though, let's observe that. We're here June 1st at 22:30, 10:30 or so, but if we go forward, we will see as we go forward that things do move, or more appropriately, the Earth moves. And as we move around the sun, our view outwards does change. It changes slowly though, changes over the course of an entire year. And so as we reach all the way to June 30th, we can see the sky is a little bit different, but Virgo is still there, Arcturus is still there, the Big Dipper is still there, Leo's still there as well. The biggest change that we will see though is the planets. As noted at the very beginning, Venus will rise up from the horizon and it'll sink back down, becoming better and easier to see. But by the end of the month at this time, 10:30, Mars will have sunk way down to the northwestern horizon, almost really disappearing from sight as it also goes around the sun. So that change is dictated by our motion around the sun, or the planet's change is dictated by the Earth's motion around the sun, as well as the planets themselves. Looking further along, though, something that does get a little bit easier to see is further over to the south, a constellation we best see during the summer months and the counterpart to many people's favorite winter constellation. Over here, we have Scorpius the Scorpion, marked out or easily found by the bright red star Antares at the heart of the Scorpion. This is a fantastic constellation. It works so easy to see, a distinctive hook shape in the sky. A little further into the night here, all the way to 11:30 or so. A very nice hook shape in the sky, ending at the star Shula there. Now, many of you might know Scorpius as well. If you're a Disney fan, movie came out, a few years ago now, I guess. It's getting a little on. The movie Moana featured Maui's hook, which is the back of, as we see it here, Scorpius. So many cultures all across the world, people all across the world, all across time have observed the night sky. They put the stars together in ways that are important to them. Maui's fish hook, most notably giving a way for Polynesian Pacific Island navigators to find their way across the ocean. It's amazing. You can, in fact, just with the stars, you can find your way across thousands of miles of seemingly empty ocean. All right, now, few more constellations I'll point out, as well as a couple more deep sky objects. All right, in fact, let's go up from Scorpius then, because I see one of my favorite stars marked out. Now, as we get into the summer, looking for bright stars in a way gets easier and harder. Easier because we're looking near the center of the Milky Way galaxy. In fact, right above the tail of Scorpius, right about here-ish, we find the center of the Milky Way. Although I've clicked on LDN 1754, which is not what I wanted. But we see the center of the Milky Way in that general area. So surrounding it, we see a greater concentration of stars and gas and dust. And that's all much easier to see in our summer months as we face towards that part of the galaxy. So there are more bright stars to see. That also means it can get a little overwhelming. The names marked out here do mark out some of the brightest stars, the ones that will be a little bit easier to see. We see Antares, for example, marked out again. Arcturus back higher up to my right on my screen. And almost dead center, looking to the south, little south-southeast here, we see the star Ras Al Ghul. This is the brightest star in the constellation of Ophiuchus, or the Serpent Bearer. Now, I know that I've got the pronunciation a little bit wrong on this one, Ras Al Ghul. I say it like that actually because I'm a big Batman fan. And if you look into the naming of both stars and Batman characters, Ras Al Ghul is the head of the demon. And Ras Al Ghul, the star in Ophiuchus, is the head of the Serpent Bearer, which even before I turn this image on, if you knew your Arabic, you might have been able to tell what it is. The Serpent Bearer here is carrying the constellation of Serpens Caput and Serpens Cauda. And there's Cunam, the shield that I clicked on. It's carrying it across the sky. In different mythologies, in Roman mythology, for example, Ophiuchus was known as Acephalus. This was a healer who learned the secrets of immortality from serpents. Acephalus brought immortality to people here on the earth. This actually really annoyed the ancient Roman gods, in particular Jupiter or Zeus, got really mad at Acephalus and threw a thunderbolt at him and killed him. And then Zeus put him in the sky to honor his work, which, just really says everything you might want to know about Zeus right there. Kind of a jerk, and then trying to make up for it, I guess. As we continue upwards, there are some historians out there, and my Roman history teacher is probably, my mythology teacher is probably, if they heard that, probably just crying. Going up from Ras Al Ghul, though, there's so much more here to see. We see a lot more names because we zoomed in. There's a lot more bright stars. 3 in particular, though, are visible further over to the southeast. So we see the southeast down there. Oh, and we see something else as well. But looking over to the southeast, we see the stars Vega, Altair, and Deneb. You know it's summer because we are here seeing our summer triangle, one of the simplest groupings of stars in the sky. These 3 stars make up the constellations of Lyra, with Vega, the harp. Altair gives us Aquila, the eagle. And Deneb is the brightest star in the constellation of Cygnus, the swan. Deneb is also the furthest star that we can see in our night sky. It has a distance of, we see marked out in Stellarium, about 1,500 light years. So this, I want to double check myself, but this is the furthest star that we can see in these constellations that we have filling up our night sky. Now, there is a lot that we can see here. I'm going to point out, though, something very easy for amateur astronomers to see. If you look for Vega over here in Lyra, and you look, it's a very simple kind of a box shape. Ooh, sorry, trying to bring up just the lines there. All right, it's sort of a box shape here with a sort of lid coming off it. If you look near the stars at the end, Chelyabinsk and Sulafat, looking with a small telescope in between these two stars, you can find the Ring Nebula. This is an amazing object to look at. The Ring Nebula is a planetary nebula. So this is the end of a star's life. In fact, the end of a star like our sun's life. At the end of our sun's life, or the end of an average sized star's life, it will expand outwards. The outer layers will actually puff off into space. The inner core of the star, the very, very center, will shrink down, and gravity will pull it down or compress it, and it'll become a white dwarf. The energy from the white dwarf will help to ionize, to heat up the gas of the atmosphere surrounding it, giving us this, well, a structure just like this that we see here. A very bright central region surrounded by glowing clouds of gas. These are beautiful, planetary nebulas are beautiful objects. There's multitudes of them scattered across the sky, and they're always worth looking for. Starting with the Ring Nebula, or M57, I think that's the way to do it, because it's pretty easy to find, it's pretty easy to see as well, and it gives you an idea of what to look for in the future. If you're looking with your own eyes through a telescope, you're not going to see those colors there. I'm sorry to say, those come from different filters attached to, again, the Hubble Space Telescope. In fact, in my observations, the way I've heard it described best is that the Ring Nebula looks like the ghost of a Cheerio. So look for that in the sky. All right, there is so much more up in the sky that I want to talk about, but we are reaching towards the end of our allotted time. I'll bring up the rest of these constellations here. If you get a chance to go out throughout June, whether it is June 1st, 2nd, or the 30th, as we're looking here, there is so much that you can see. So I hope you get a chance to go out and observe this. But I'm going to come back to Amber, actually, who's been watching our Facebook feed. And how many people laughed at all those great jokes, Amber?
I think quite a few. They just didn't say it in the comments.
That's what I choose to believe as well.
Yeah.
Right.
So the first question actually comes from Laura. And when you were talking about being able to see the International Space Station, Laura actually had a question about when and if you can see the SpaceX Starlink satellite.
Yes, you can. In fact, as I've been setting up for this program today, I have actually been able to see them here in Stellarium. I'm going to turn them on, all our satellites on here. So Stellarium gives you a lot of options. And I'll actually try to slow us down a little bit here. So I should get two answers here. I'm showing this in Stellarium. That was for my default go-to. But you can see it in the night sky as well. They might be a little hard to see since it's a screen share here. But the Starlink and other satellites are visible as these little dots of light are really just streaking across the sky. If you go outside at night, they'll look the same though. If you're looking for something like Starlink, there are sites set up online, I believe. If you Google around for them, I'm sure there are sites out there to tell you when to look for them. And they'll truly look like little bright points of light. They'll go across the sky. And I think some key things about them is they'll be very steady points of light. So they won't twinkle, they won't go suddenly, they won't flash or anything. They'll just be a pretty consistent light that fades up, is bright, and then fades down pretty much instantly. That's the defining marks of a satellite in general. The Starlink satellites as well, there are the trains of satellites, so the rows of them. So tracking down the Starlink satellites can be easier in a sense, because if you're seeing a few of them right in a row, can be making pretty good confidence you're looking at the Starlinks. And of course, in the next few years, it'll be even easier to see them. I believe the plans are to put up something like 30,000. The number keeps going up and up the more every time I hear about it. So thousands of Starlink satellites are projected. And unfortunately, I would say they're going to be even easier to see.
So Rolf also had a question about satellites and is just wondering more about the impact of them in terms of how and if they're recaptured, and what, if any, impact you think all that metal and aluminum might have on our climate and our planet.
Yeah, I think the biggest impact we're going to see is not necessarily on things like our climate, the atmosphere. The biggest impacts are going to be in visual and truly observational astronomy. So both amateur and professional astronomy. There are plans to work around this to make satellites darker, to make sure that they don't reflect a lot of light back to us so that things are not disrupted. But unfortunately, as it stands right now, those plans are plans. Satellites are bright. They reflect the light of the sun. There's a Cosmos 2151 going across. They reflect the light of the sun, and they reflect a lot of it. We can see them with the naked eye. And when we look with cameras, when we're doing observational astronomy or research astronomy, they overwhelm camera sensors. With thousands of them planned, I don't think this is going to be very good for astronomy, in my opinion, at least. Plans to darken the satellites, to literally paint them black, or to change their orbits as well, will have some positive effects, but just the number of satellites going up is going to be a problem. As well, as sort of alluded to there, they go up there, they work, hopefully for a long time, and then they stop working. Satellites do end up, their electronics, they will fail over enough time. And as they do that, they need to be moved to either what we call graveyard orbits, where they are moved into more stable orbits, usually higher up, tens of thousands of miles away, or deorbited into the Earth's atmosphere where they burn up. Both of those take more planning, more time, and more money. So jury is still out on how exactly all of that will work out in the next decade or so. Try not to be a pessimist here, but I don't know. I'm not super thrilled about some of this. The work going on from these satellites is very important. I will say what they are doing is very important, but we need to think about these long-term effects too. And I'm just tagging all the Starling satellites I see as I watch my screen here. Stellarium does update the satellite elements. So when you load it, it actually does show the correct positioning, at least in the near future. This is the way actually that I was aware that I was looking at a satellite a couple weeks ago when I was observing, and I was very confused because it looked like Arcturus was moving, and I thought something had gone horribly wrong with the universe. But no, it was just a satellite, and I felt a little silly. Other questions, Amber?
Yeah, the last question actually comes from Corey. It's a different type of moving object. Corey's wondering, when is the next big meteor shower?
When is the next big meteor shower? Oh my God, that is a great question. I'm actually gonna have to look that one up right now because I don't remember. The one that does come to mind is actually the Lyriads meteor shower. I want to make sure I get the dates right though. Meteor showers are named after the constellations that they appear from. So when we see those streaks of light burning up, the rocks burning up in our atmosphere, they all appear to originate from a point in the sky. And well, let's take a moment to try to find Lyra again. So the Lyriads come from the constellation of Lyra, or the Harp. We've come all the way here to 2 o'clock in the morning. So now we're looking at a very different sky, but you know what? Some things are still the same. I've got our Milky Way marked out, which really helps us. And I know from the Milky Way that I can find the Teapot of Sagittarius. So handle on the left, lid on the top, spout over there, you sing the song to yourselves. If you come up from the teapot, whoa, there's a lot of bright stars up here, but if we continue upwards, there's a brighter star, and that is Altair right over here. Altair is part of our summer triangle. If I keep going upwards along the Milky Way, I know I can find Deneb, and I know the super bright star, in fact, the fifth brightest star in the entire sky is then right over here, Vega with Lyra. And I can also help myself out just by putting up the labels there too. The Lyriads is the meteor shower that comes to mind. That would appear to be from the constellation of Lyra. But I'm not 100% sure on the date of that. So I'm gonna double check myself here. I try to lie to people as little as possible when it comes to meteor showers because they are so cool. Generally speaking, I try to lie to people as little as possible for everything, but especially meteor showers. All right, double checking the Lyriads. The Lyriads actually peak during April. Ooh, so not during our summer months. So what is coming up in our summer months? Well, the American Meteor Society has a great website, and I am very sure that they list when meteor showers are happening. And look at that, they do. American Meteor Society, it's a hard name, Meteor Shower Calendar for 2021. All right, looking at this, scrolling through, it looks like a next meteor shower coming up might be around, well, we're in the middle of the Eta Aquariids. So the constellation of Aquarius gives us the Eta Aquariids. And it also looks like the Aquariids are happening. There's a different meteor shower from the Aquariids happening near the beginning of July as well. So the Aquariids would be the next major meteor showers coming up. Marked out here in Stellarium, though, I turned them on too, just to give you an idea of what that looks like. Marked out in green are some different meteor showers. There are multitudes of these. We see the Ophiuchids happening here. Is this going to give me a date? It does. Look at that. From the end of right now, in fact, throughout July, it's a fairly low meteor shower. On the upper left, the ZHR of 6 means a zenith hourly rate of 6 meteors per hour. Not super bright. The June Scotids are just about 2 to 4 at the end of June. Other ones like the June Botiids, great names here, right? Are an intensely variable meteor shower. Stellarium's giving an hourly rate of anywhere from 0 to 100, which is not helpful. That one, I would say, though, would probably be worth looking for. It looks then our activity peaks near the end of June for the June Botiids, naturally enough. If you want to see the Botiids here or any of these meteor showers, it is one of the easiest things to do. It's why I love meteor showers so much. All you need to do is find dark skies, even skies inside the city. You need clear skies, so wish the clouds away. And then you need to go outside. That's key. And then you just need to look up. That's it. No equipment, no binoculars, no telescopes, just your own eyes looking up at the sky. Meteors are these bright, brief flashes of light in the sky. They can appear almost anywhere, so you don't want to restrict your view in any way. You just want to look up. And during the summer, even if we don't have some super bright ones going on, it is great to do that because, you know what, it's warm again. It is not the freezing cold that we have had. And that means that you can spend longer and longer outside. I would be remiss if I didn't mention, although I totally forgot up until this point, June 20th as well is our summer solstice. It's the first day of summer in June. So a happy solstice coming up here. But yeah, meteor showers are amazing. Check out the American Meteor Society, their meteor shower calendar. And then, you can look it up yourselves.
Thank you so much, Tad. So yeah, I think we're all looking forward to those warmer months, and hopefully this has inspired everyone to head outside with your eyes or binoculars or a telescope if you have one, and start do some perusing on those warmer and clear summer evenings. So before we head out today, we do want to thank Ruth and John Huss for their continued support of the Bell Museum and in our pursuit of becoming Minnesota's astronomy classroom. So thank you once again for joining us for this online version of Minnesota's Night Skies. We hope to see you soon at the Bell Museum. We hope you have a wonderful evening.
Thank you, everyone, and please continue to stay safe.